Okay, here's example 2 from 14.5. Here's where we're going to get into a little bit more of the real world or application problems. Example number 2 says you have a small rock and it's dropped into a lake. Circular ripples spread over the surface of the water with the radius of each circle increasing at a rate of 3/2 feet per second. Find the rate of change of the area inside the circle formed by the ripple at the instant when the radius is 4 feet. So imagine that scenario. You throw a rock into a lake, it kind of makes circles as it kind of ripples out, and that circle is going to change, right? And that circle is going to change over time. That means the radius is going to change over time, the area is going to change over time, and so what we're trying to do is find the rate at which that area is changing at the exact moment we're talking about. As soon as that radius hits 4 feet, how fast is the area changing? Okay? What I'd like you to do is follow a few steps. The first thing I'd like you to do is list all of your givens. List all of your givens, but using proper calculus notation. So going back into the word problem, if I was reading this again carefully, it says here that the radius of each of the circles is increasing at a rate of. That means that's the rate at which the radius is changing over time. Can we call that dr dt? And it says here that dr dt, the rate at which the radius is changing over time, is 3/2 feet per second. So that's my first given. It asks us to find the rate of change of the area. So at that exact moment we're talking about, I want to know the rate at which the area is changing over time. Can I call that dA dt? Again, the rate at which the area is changing over time. That's what we're trying to find. It says as soon as the radius is 4 feet. So my other given is that the radius is 4 feet. When the radius is 4 feet and the radius is changing at a rate of 3/2 feet per second, how is that area changing at that exact same moment? So right now, those are our 3 givens, okay? The next thing I would like you to do is I would like you to come up with some sort of an equation or formula that relates all the stuff that we're talking about together. So what formula do we have that relates radiuses and areas together? And really, radiuses and areas of what shape? Well, a circle, right? And so over here, we have the formula for area of a circle. Doesn't that formula relate radiuses and areas all together in one? So I'm going to actually start with that formula for area of a circle. Area equals pi r squared. And what we want to do is we want to find the rate at which all this stuff is changing. And again, what's another word for rate of change? That means we really want to find the derivative, right? We want to find the derivative with respect to time. As time goes on, how is all this stuff changing? The derivative with respect to time. So the derivative of a with respect to time, is dA dt. Remember, pi is just a number, so I'm going to leave that number chilling out in front. I'm going to find the derivative of r squared, which is 2r, but remember, we need to add a dr dt because the radius is going to change over time. Okay, so I found the derivative with respect to time, and then hopefully we have all of our pieces that we need. Don't we know at this exact time the radius is 4 feet? We know at this exact time that the rate at which the radius is changing is 3/2, and we're trying to figure out what dA dt is, the rate at which the area is changing. So in my next step, I'm going to plug in, all of those, where did we go? Sorry. We're going to plug in all of those different pieces. So for the radius, I plugged in 4 feet. For the rate at which the radius is changing, I plugged in 3/2 feet per second. I put the units in there to help me kind of remember and figure out what the units are going to be in my final answer. From there, I just put it into my calculator. I'm going to put in 2 times pi times 4 times 3/2. You should end up getting 37.699. Now, that 37.699 means something, and I want you to be able to write a sentence, remember with the 3 things, interpreting what that actually does mean. So, when does it happen? What is happening? And what is your answer with correct units? So, when is this happening? Well, when the radius is exactly 4 feet, dA dt means the area is increasing. Well, how did I know that the area was increasing at that moment? Well, remember, if your answer is positive, that means you have a positive rate of change, an increase. If it was negative, it would be decreasing. So When the radius is 4 feet, the area is increasing by 37.699 feet squared per second. Again, that helps me over here when I put my units in. I have a foot times a foot, so I have a foot squared per second. And if you think about it, the area changing, isn't area always in units squared? And if this is a rate of change, it's how time is changing, how the area is changing with respect to time. So then my answer would make sense to be feet squared per second. So again, when the radius is 4 feet, the area is increasing by 37.699 square feet per second at that exact moment. Okay? It's called related rates. Follow those 3 steps. List your givens, find a formula that relates it, and then find the rate at which all that stuff is changing with respect to time. Okay? I'll stop the video here and do the next example in the next video.